Okay, good afternoon. So today we're going to continue our discussion on time value of money. So far, we have learned how to make use of the PV function, the FB, rate function, NPER, and and PMT function. All of the 5 functions that it's important for time value of money problems. And also we learned how to make use of NPV and IRR. By way of review, given a certain cash flow distribution with a certain initial investment, you can compute for the net present value in 2 ways. Number one is to convert each of this as a present value, and then you add. You are able to add this converted cash flows since they are now equivalent to cash, equivalent to present values. Okay, and we said that if the present value is positive, then uh, the decision rule is that the investment is solid, means it's a good project, it's feasible. So a positive net present value from a financial perspective indicates that that's a good investment. Another way to to determine whether a project the NPV is by using the NPV function. So this is NPV function. The only thing that we have to remember here is that the NPV function is computed based on the future cash flows. So that if when we use this, we started with C56, this one. We excluded the initial investment. Otherwise, if we included this will be treated as occurring after 1 year, at the end of the first period. And then we just add it back, C55. Okay, so we got the same results, 1652, 1652. And then we learned how to make use of IRR, the internal rate of return. And here, Excel is correct, including the initial cash flow. And then the value that we get here, 15.47%, is then compared to your weighted average cost of capital, the cost of capital of the firm. If the internal rate of return is greater than the average cost of capital, weighted average cost of capital, then we say that the project investment is feasible. So the IRR has to be greater than the WACC. Otherwise, if the IRR is less than WACC, then we reject the project. Now, sometimes there will be instances when the NPV and the IRR conflict with each other. They conflict. So, for instance, NPV says reject the project or accept the project is okay, and then IRR says no, okay, or vice versa. But it's usually IRR says okay, then NPV says do not. Okay, so do not go the project. So what's done here is that I'm sorry, I stand corrected. We have to adjust the IRR because there are some assumptions that were made in computing for the IRR. So when there's a conflict between NPV and IRR, it's always the NPV that prevails. Okay. All right. So now we're going to the next lesson, which is we have non-annual compounding periods. You oftentimes meet a scenario where you have an investment and you're given the interest rate, and then you're told that the compounding is done not annually, but let's say semi-annually or monthly. Okay, so now if compounding is not done annually, and if it's done semi-annually, it means the interest is computed twice a year. Okay, so from the perspective of the investor, this is better, this is good, because interest is computed more than once a year. So if it's semi-annual, then interest will be computed twice a year, quarterly will be 4 times a year, etc. So this problem calls for determining whether it's better to have your investment compounded annually, semi-annually, quarterly, etc. By taking a look at this example, we're investing 1 million now, and the annual rate is 10%, and we're going to invest it for 30 years. Okay, if the interest was compounded annually, how much will be the future value? What if it was semi-annual? It means that interest is being computed twice a year. Or if it's quarterly, etc. What would be the future value? Because by computing the future value, then we would be able to determine which of these options is better. Is it better to have daily interest? Okay, conceptually, of course, you'd think na, yeah, of course, it's better to have the interest computed daily, because that means that if you have an interest today that will be added onto our initial investment, then tomorrow the basis for the interest will be higher. Okay, because we have already added the interest for this rate. Okay. So what I want you to do is I'm going to give you a few minutes to compute for the future value. Okay. Just one formula, and then copy down to infinite, to 365. Do not do yet infinite. I'm going to explain that separately. And then let's see which indeed is better between annual compounding, semi-annual, bi-weekly, weekly, even daily compounding. Okay, I'm going to pause the recording first, and then I'll give you maybe 2 minutes, 2 to 5 minutes. And then I just want you to put a formula here and then copy it down. Okay? As students of finance, we should learn how to make our work, our spreadsheet model efficient, because it will be unwieldy if we're going to write the formula for each one of these. Okay, are there any questions? Okay, no questions, then pause recording. Okay, let's compare answers. Kindly check if you got these answers, at least up to 365. Okay, you should have gotten, if you copy the formula down, you should have gotten 20077 to 8285 in the daily compounding. Otherwise, if you didn't get this, then something's wrong with your formula. Okay, so let me compute for this. Okay. Now what I did was to give these cells a name. If you take a look at this, I'm having here present value, and then years, and then annual rate. Okay, so you know how to do that, class. You can highlight this, then Control Shift F3. Okay, Command Shift F3, I think in Mac, right? And then give this cells a name, the left column. All right, so that it's easier for us, and even avoid doing the $sign. Okay. Now, what does this mean? The annual rate, when you're given the rate, the interest rate, it's always assumed to be annual. Okay, always, unless there's a specification that it's semi-annual, etc. So that 10% is an annual rate. Now, if we're going to do a semi-annual rate, if we're going to do semi-annual computation, how many times each year will the interest be computed? Kindly chat, please. How many times every year? Yeah, thank you. How about the others? Thank you, Luis. 2 times, twice, sabi ni Luis, twice, sabi ni Kim, correct. James, okay. Sino sabing once? Okay, wala. Twice pala yan. Alright, so you're correct. 2 times a year. Kasi semi-annual, no? Okay. Tapos, when you compute for the first interest, how many months in that period? How many months? First interest, for example, for the year. How many months are we counting? How many months? Yes, 6 months. So 6 months before the interest is computed. Therefore, in 1 year, you said that 2 times 2 times a year will the interest be computed, right? In other words, 2 times a year means 2 periods per year. There will be 2 periods of computation of interest. Okay, therefore, there will be, what will be the interest per period? What will be the interest per period? The annual rate is 10%. Therefore, the interest per period will be how much? Okay, correct. 5%. You're correct. Luis and Rod, that's right. It's 5%. Okay, 5% for the first 6 months and another 5% for the next 6 months. So that makes 10% all in all. Okay, so the when we use FV is equal to negative FV, okay, what would be a rate? Take note, our rate will depend on the periods per year. If it's annual, then it's 10%. If it's semi-annual, how much will be the interest? You chatted a while ago that it's 5%. Okay, so what do we do with the annual rate? To get the effective rate, to get the interest per period. So you divide the annual rate by the periods per year, right? Yeah, divide to correct, no? Thank you, Jillian. That's correct. So the interest rate divided by the number of periods per year. All right, so let's do that. So the first one is rate. So here I have annual rate. And then we said that the annual rate, the 10% is if the compounding is annual. However, if it's more than once, then the interest rate will be the annual rate and then divide it by the periods per year. Okay? So that when I copy this down, the rate will be 10% divided by 2, 5%. That's for semi-annual because we're going to compute the interest 2 times a year. All right? So we don't need to fix this because this has already been fixed by the name that we gave it. Okay, comma. What's N per? Again, N per will depend on the number of periods per year. If it's annual, then the 30 years will be the same number of periods. However, if it's semi-annual, then since you're computing interest 2 times a year, then it will be your years, and then we multiply this by the periods per year. So when we copy this down, it will still be years. The years is 30, and multiply that by 2 with the semi-annual. So that's 30 times 2. 60 periods. Why 60 periods? Because semi-annual is 2 times a year. If you have 30 years, so how many periods will be the computation of the interest? It will be 60 periods. Okay? So we divide that by, we multiply that by the number of periods to get the number of the N per. Then comma, PMT, this is not a PMT, this is not an annuity, rather this is a single cash flow. The present value is this one, the present value. And then for the type, we can ignore it because this is not an annuity. And then we expect to get a negative answer here. So I'm putting a negative here in front, or you can put a negative here in the present value. And you're going to get also a positive value. Okay, so Control Enter. We have this. So your 1 million today, in 30 years time, it will earning at 10% interest compounded annually. That will be 17 million.449. Now, if I copy this down, okay, you notice that the more the compounding per year, the greater will be your future value. Natural plus, of course, because interest is computed on interest. So if for the first 6 months you compute interest, then whatever that resulting amount is, you will still have to compute interest on that at the end of the month. So you have now a bigger principal, okay, because you added already the interest for the first 6 months. So you can see here the difference between annual compounding and semi-annual compounding. Okay, of course, if you're the investor, you'd like to have more compounding per year because your money will earn interest on the interest. However, if you're the borrower, you don't like this. You would not want that that the compounding of the interest will be more than once a year, okay, because you'll have to pay more. Okay, so if we copy this up to the weekly compounding, so you can see here the difference between among the different compounding periods. So the more compounding every year, the greater will be the future value. In fact, if I go down here for the daily compounding, so you can see here that wait, did I make a mistake? Sorry. Yeah, it's correct. This is 20077. This is 20027. So the cash flow with the higher compounding per year will be the better cash flow from the perspective of the investor. But if you were the one borrowing the amount, of course you wouldn't want that because the lender will now earn interest upon interest. Okay, so it depends on whose perspective, what perspective or role you're playing. If you're the investor, you would want more than one compounding per year. Otherwise, on the other hand, if you're the borrower, you wouldn't want that because the future value of that stream of cash flows will be bigger. Okay. So how about for the infinite? Okay, if it's infinite, then definitely that should be more because infinite compounding is more than daily compounding. Okay, so how do you compute for an infinite compounding? All right, so it's the same formula. In fact, you have it here. Okay, so kindly, the formula is there. Kindly put that in whatever color. I made it colorless so that you won't see. But now you can see that the future value is equal to the present value times exponential e to the rt, okay, e to the rate times time. And you should be getting 20,085,536. Okay, I'll give you 1 minute to please key in that formula there. And please chat yes if you got the answer. Okay, I'll wait for your yes class. You should be getting 20,085,536. Resume recording and I'll stop share first. Gerald, could you kindly share your screen and tell us what you did? Si Rhea may answer then. Okay, Gerald. Okay. Could you explain your answer, please?
I just this is PV B68, but I think
Okay.
I forgot to name it though.
It's okay.
And I didn't really know what E was, so I just like searched the
Mhm. The
thing.
web.
I
Okay.
searched. I
Go
was like,
back. Okay.
and then I found this thing,
Okay.
and then I used it, found the exp function.
Yeah. Okay.
Then I just added this annual rate, and then I multiplied it to the use, and then I got the
Okay. All right. Thank you. Thank you, Gerard. Okay, that's correct. So the E, the number E, let me share once again my screen. Remember, class E is, let's just do that again. EXP, the first power. So this means E to the first power. What's inside here is the exponent. And, I'm sorry, I forgot to put equal sign there. So remember, the E is approximately equal to 2.72, first two decimal places. It's a transcendental number. It's an irrational number. It's just like pi, non-repeating, non-terminating. So you can use a very powerful computer, microcomputer, and then you can ask the microcomputer to generate that number to compute for E, and then it will be infinite. It will never end. Okay, so you're correct. Thank you, Gerard. And Rhea, I think also had the same answer. That's correct, Rhea. So that's a present value. Let me get the present value. Multiply that by E. So this is your E, exponential E raised to the T, R times T. I have my annual rate multiplied by my years. Okay, there. Okay, so it's the present value multiplied by E raised to the R times T. Okay, if I take a look at this is, okay, that E times RT is 20.085. Okay, so let me put it back. Okay, so we can see here that the continuous compounding or infinite compounding will of course give us a higher value, future value. Okay. All right, any questions so far? I'll appreciate if you please chat and please tell me if everything is clear. Any questions, any clarifications? Okay, waiting for the others. Okay, good. Thank you. All right. Now you can see here that the annual compounding will of course have a lower future value compared to those that have more than one compounding per year. Because as I said a while ago, this happens because interest is computed more than once per year. So if you compute interest and that interest will earn interest, there will be interest on interest, then definitely you'll have a bigger sum, you'll have a bigger future value. Okay, therefore, the rate function, the effective rate, okay, since they have different future values, then we can say that effectively, those with more compounding per year will have a higher effective annual return or EAR. Definitely, definitely. So the nominal rate is 10%. However, you have here different compoundings per year. And based on the future values where the future values of those with more than one compounding are greater than the one with just one compounding or annual compounding. Therefore, we can say that the effective rate of these other cash flows, of these other future values, will be higher than the annual. The effective rate for the annual is also the nominal rate. So this is the nominal rate, this is the annual rate. That's the nominal rate. Okay. And since the annual rate is 10%, the nominal rate will also be 10%. Okay, so I'm now going to ask you to come up with the effective rate. Let's first use this formula. If you take a look at this, I gave you here the formula. The effective annual rate is equal to, so I need to edit this because there should be a -1 here. Okay, -1. So kindly fix that formula, please. Okay, so the effective annual return is equal to 1 plus the nominal rate divided by the periods per year raised to the periods per year and then -1. Okay, so I'll give you a few seconds. Kindly compute for the effective annual return using the formula function. Okay, and of course, we will not be able to compute for the perpetuity since here you're asked for the periods per year. And for continuous compounding, there are no periods per year. So just leave this blank first and let's see. Okay, let me once again pause. Okay, so for this one, the using the formula which I shared with you here, it's equal to 1 plus the nominal rate divided by the periods per year. So that this one, nominal rate divided by the periods per year, that's your interest per period. And then we raise it to the number of periods per year and then subtract 1. Okay, so that will be equal to 1 plus the nominal rate is our annual rate, right? And then we divide this by the periods per year, which is this one. Okay, so annual rate divided by 1, that will still be 1, and then raise it to the periods per year. So for the annual rate, and then -1. For the annual rate, it will be the annual rate, which is 10% divided by 1. So that's 10%, right? And 1 plus 10% raised to this one is also 1. So 1.1 raised to the 1 is equal to 1.1, right? And then subtract 1, 1.1 minus 1, so that's 0.1 or 10%, which is the annual rate, right? So the effective rate for the annual rate is the annual rate itself. Let me check. All right. So anyway, we're evaluating your answers. So if I enter this, I'm getting 10%, of course. Let me increase the font, the number of decimal places so we can see it more. Maybe 5 decimal places. Okay. And then I copy down. Okay, here you can see that indeed, if you have more compounding per year, then the effective annual rate becomes bigger. In fact, for daily, it's 10.51 compared to 10%. Now, of course, this will become really, you might say that the difference is marginal. Well, it depends on the cash flow where you're looking at. If this was a government budget, let's suppose this is 100 million, 1, 2, 3, 1, 2, 3, for example only. The effective rates will still be there, However, you can now see that the differences in the amounts. Okay, so this is 1 billion, 1.74 billion, and this is 2 billion. So you notice the power of compounding, the difference. If it's annual, semi-annual, etc. Okay, and for this one, again, I already gave you the formula. Kindly, your effective rate is your e to the I. So this is equal exponential raised to the I, which is your annual rate. Okay, e to the I minus 1. All right. Let me just make this in percentage also. Okay, you can see that we already expected that the continuous compounding will have the biggest, the highest effective annual rate. Okay? All right, any questions so far? Clear so far, class? Kindly chat, please, in the chat box if our discussion has been clear so far. Okay, thank you. 1, 2, 3, 4. How about the others? 5, 6, 7. Any more comments? Kung clear siya? Any questions?
Hello, sir.
Yes?
Sir, yung sa infinite po,
Yeah.
the formula is E
E to the I minus 1. Let me flush that. So that's E to the I. Your I is your nominal rate. Okay?
Yeah.
E to the I and then minus 1.
Okay, sir.
Okay?
It's not raised like it's E times I, right, sir?
No, no. In Excel, this is E to the I. No, it's
Okay,
not E
okay.
times I. Okay? The exponential function of Excel, this is raised to the I. So it's not
Okay, sir.
E, because E itself, okay, if I want the number E, as I mentioned a while ago, it's E to the first power. So you have to
Okay, sir.
raise it to a certain power.
Okay, sir. Okay.
Okay? All right. Yeah. Thank you. Thank you for
Thank
the
you, sir.
maybe I should change this. I should change the I here to the nominal rate. Okay, and superscript. Be more clear right here. E to the nominal. E to the nominal minus 1. Okay, good. Good question. Thank you so much for the question. Okay, now I'll give you 1 minute. This time, use the rate function to compute for the effective annual return. And with the rate function, you can, okay, let's see. Recall the syntax. The syntax for the rate function will be n per number of periods, PMT, PV, etc. Okay, so use that in order to compute for the effective annual return. Use for this cash flows, future cash flows based on different compounding periods. All right, I'll give you a minute. Okay, done, class? So you should be getting the same the same answers. 10%, 10.25, 10.3, 81, 28, 29, etc. Okay, were you able to get this? Chat, please, if you were able to get that. If not, I'll discuss. Okay, thank you, Luis. How about the others? No, okay. Thank you, Rod. No, okay. Okay, clear. Okay, thank you. All right, so some of you were not able to get it. Let's do it, class. I'll delete this. Okay, thank you. All right, so we use the rate function is equal to rate, right? Rate. Our NPER will be, what's our NPER, class? What's our NPER? So what we want is to, okay, compute for the effective rate. Okay, our NPER will be years, right? So that's 30 years. 30 years. We're not going to compute for the periods. Otherwise, what we will be getting is the nominal rate. Okay. So what we want to get is the effective annual rate. So how many years? Okay, 30 for us to get this amount. So there's no annuity. This present value. Okay. Sorry, the present value. I'm sorry, it's wrong. The present value is present value. Okay, comma, and the future value is this one. Now remember, you should make sure that one of these cash flows is negative. Okay, you can use the present value to be negative or the future value to be negative. At least one of them should be negative. Okay, and then that's a future value. The type ignore because this is not an annuity, and then guess you can ignore. All right, so enter. So that's 10%. And then if we copy down, okay, take a look at the formula. Years, present value, and then this one. So we can copy this down, right? Because we're just using the 30 years. So we're asking, what's the effective rate if I have 1 million now, and then 30 years, it will become 2008. So using the rate function, I'm getting 10.51709%, which is the same as this one. Okay. Oh, my screen is not showing. I'm sorry.
I think
Oh.
naka-pause po ata.
Yeah, I'm sorry. Yeah. Sorry about that. Okay, let me repeat that. Okay, so we have here rate. Our NPER, as I mentioned, is your years. So we have 30 years, right? And then PMT ignored because this is not an annuity. PV is your present value. We have named it present value, comma, our future value is this one, right? So I make sure that one of them has to be an outflow. Either the present value is an outflow or the future value is an outflow. Let's make it the future value. You may try to make it the present value. It doesn't matter. Okay, Control Enter, and I'm having 10%. If I copy this down there, okay. Now this worked also in the continuous compounding because the parameters that are required are the years, the present value, and the future value. Okay. Any questions? Any questions, class? Thank you. Okay, kindly chat, please, if it's clear. Okay, thank you. All right, good. Okay, thank you. Okay, and the last is the effect function. So this is very easy because there's a function called effect in Excel. So it returns the effective annual interest rate effect, and the parameters are you're asked for the nominal rate. So we know the nominal rate to be the annual rate, and then copy the N per Y, the number of periods per year, which is this one. Okay. So that's about it. And of course, you cannot use it here for the continuous because this will not be read by Excel. Okay, kindly try, please. Control Enter. Then let's just copy the formatting here. Right. And see, class, if you have the same answers. And please chat if you got the same answer. Okay, thank you. Let's wait for the others. They got the same answer. Okay, good. Good. Okay, so if I copy this down, okay, I can't copy this down because this will not do it. Okay, so this one. So we cannot use the effect function for the continuous, the perpetuity. All right, so, okay, that ends our discussion for this particular worksheet. Any questions before we go to the next for this specific worksheet?
I have a question.
Yes, sure, go ahead.
Did you use the same formula for the infinite in the rate? As in
Yes,
the DA?
yes, okay, yes. Because the parameters are years. The years are the same for all, 30 years. Okay, and then we have the present value, which is present value is 1 million, and then they differ in the future value. Okay, they differ in the future value. Of course, if the future value is greater, then definitely the rate will be higher.
Okay.
So, was that you, Gerard?
Yes, sir.
Okay, good. Thank you. Thank you for that question. All right. Any other questions, class? All right. So no more questions. Let's now go to amortization. Okay, so I think I gave this to you. Now we will just be able to finish this. And the next meeting we'll have the dynamic amortization schedule. And then after the dynamic amortization schedule, we will be going to yield curves. Now that's very interesting to study now because there's a, in the United States, they're predicting that there will be a recession. Okay, they're predicting that they're closer and closer to a recession. So we're going to use the yield curve to try to see if indeed there might be a recession in the US. Okay, and there's a way to predict that. And you will see that we'll use historical data and see that when this happened, indeed there was a recession. And it's a fail-proof indicator that there will be a recession. Okay, but first let's go here and learn how to construct an amortization schedule. Okay, we're going to use as an example the Pag-ibig amortization schedule. Let's see, could you kindly, let's see if we can HDMF amortization. Let's see, HDMF, that's Home Development Mutual Fund amortization calculator. Let's see if we can find this here. Let me go here, Pag-ibig housing loan. This is not what I want, but let's see. Okay, so maybe not this one. Okay, back. I'm having a problem with this one because I tried accessing it and see. I don't know with you, class. Do you get this? Error, page not found.
Same problem, sir.
Oh, nga,
Yeah, I also have there.
Okay, it used to be accessible. I don't know why. Maybe let's try another. Okay, mortgage calculator. Let's see. Okay, this one. mortgage calculator with monthly amortization. Okay. Okay. Anyway, let's use this, but this is not good because the other one has a plot that we can use. All right. So let's assume that we're buying a house and we're going to loan it from Pag-ibig. The amount is 5 million, and usually you'll not be able to borrow everything. You'll have to have an equity. Okay, so let's suppose that the equity that you're going to contribute is 20%. Okay, 20%, and then let's assume that the mortgage term is 15 years. You can use 5 years, 1 year, 2 years, 10 years, etc. So the interest rate is 10.5%. Okay, let me check if this changes. 10.5. Okay. The loanable amount is, I think, up to 8 million. Does not change. Let's see first. No? Let's see first what are the rates, because the rates are depending on the amount that you're going to borrow. Housing loan rates, Pag-ibig. Housing loan rates. Okay, here, frequently asked questions, housing loan rate. Let's see. Okay, the Pag-ibig housing loan allows you to borrow up to 6 million under very low rates, very competitive as compared to borrowing from a bank. What can I do with the Pag-ibig loan? Okay, let's see. You may use this to purchase a fully developed residential lot, not exceeding 1,000 square meters. Can purchase a pre-owned or brand new units, etc. Okay, let's see. How do I qualify? You should have age of not more than 65 and not more than 70 at maturity of the loan. At least 24 monthly membership savings you should have already deposited for 2 years, okay, because the contribution in Pag-ibig is usually monthly. Okay, so there's a contribution also coming from your employer and also from you. All right, so let's look at how much can I borrow? The maximum amount is 6 million. Okay, and then here, what are the interest rates? Okay, here. So let's take a look at this. So if it's a 15-year fixing, it's 8%. So you can see that the lower the term, of course, the lower will be the interest rate, because this is consistent with the principle of risk and return. The lender, in this case, Pag-ibig, assumes a greater amount of risk if the term of the loan is higher. So naturally, they will demand for a higher interest rate to compensate them for the additional rate they're taking. So the highest interest rate as expected is 30 years. All right. So let's just assume it's 15 years. So that's 8%. Okay. So let's go to the Pag-ibig calculator, and the interest rate is 8%. 8%. Okay. All right. So here we have mortgage. Let's make it, we're loaning 5%. And then the down payment is 20%, which means that the loanable amount is 4 million, 15 years, 8%. Of course, it states there in the Pag-ibig principle that you cannot just loan any amount. They will have to assess your salary, etc., etc. Okay, there are some factors that they need to consider. Okay, because the Pag-ibig money is a fiduciary account. It's a mutual fund. It's owned by those contributing to Pag-ibig. So later on, once you join the workforce, your employer will also get your contribution to Pag-ibig, and it will also match that, so that you have a double contribution to Pag-ibig. Okay, And then once you have been working for 2 years, which means that you have been depositing for 24 months, then you can already make a loan with Pag-ibig. Okay, so let's calculate this. Let's check 5 million, 20%, 15 years, 8% interest rate, first payment February. Okay, which means that this is annuity ordinary. So which means that we loaned, if we're going to loan now, February, then our first payment will be March. Because annuity ordinary, let's assume we're loaning now, February, so the first payment will be March. Let's calculate. Okay, and you will see here, there. Okay, and then you see here the plot. So you have here the dates of the payment. So, okay. Okay, so what happened here was April was the first payment. So this was, maybe this was the loan date. I think medyo mali yung ano yan, March. Anyway, April 2023 is the first payment. This is on a monthly basis. You can see here principal, interest, and balance. So the 4 million, okay, every month, the principal balance will be going down until it reaches, okay, March 2038 is the 15th year. Okay, so there will be no more zero. There will be zero balance, which means you have paid up your principal. And what we want to replicate is this one, is this whole thing. So definitely we will not be able to finish this, but your assignment will be to produce this plot to be collected. I'm going to create a folder in Canvas, and the deadline will be by Monday. You should have posted your answer, a plot, this one, exactly the same. So there's this line. Okay, this is your principal amount, your balance. Okay, you can see that it's going down, and the yellow one here is your interest. Okay, interest. So you can see that the interest over time is going down, while the principal payment is going up here. Okay, so we'll learn now how to create the principal, the interest, and the balance, and then your assignment will be to reproduce this plot. Okay, so let's see. Okay, so let's put here the loan principal is 5 million, 1, 2, 3, 1, 2, 3. Percentage down payment is 20%. So the amount to finance will be 5 million, multiply that by 1 minus your, right? 1 minus 20%. Yeah, let me pause for a while and allow you to catch up. Okay, let's copy this table, Control C. We have that reference, Control V. And then also this other site, okay? The frequently asked questions, Control C, Control V. All right. Just in case you don't have it, I'm going to share it in the chat box below. Okay. Okay, so we know that the interest rate for this for 15 years, okay, 15 years is 8%. Periods per year, so it's a monthly amortization, so it's 12. Okay, and the monthly amortization should be, okay, I'll give you 1 minute, please, to compute for the monthly amortization. And kindly chat it in the chat box, write it in the chat box. You should be getting 38226.08. Which if we compare here, let's compare here. 5 million, 20%, 15, 8%. Okay, show by month. So this is the payment. Okay, 38226 here. Okay, total monthly payment 38226. So you should be getting this. So did you get 38226? Kindly chat, please, if yes. Okay, yes. Carlos, yes. Rhea, yes. Okay. All right. How about the others? Were you able to get 38226? The monthly amortization. So if you want to loan, the amount to be financed is 4 million. Okay, you won't be able to get a loan equivalent to the value of the item, value of the house. You have to have an equity.
I'm sorry, did you use the Excel function for?
Yes, yes. Excel function. What's the Excel function for that? Gerard, ikaw ba yung nagtanong?
Yes, I was just
What do you think is the Excel function? For an annuity, it's what? It's PMT, no?
Oh yes, sir.
Okay, it's a PMT function. Again. I forgot to make 12 to be 9. Oo, dapat ano. Okay, class, may I have your permission to continue? Because we're running out of time and we need to finish this so that you can prepare the plot. Okay, so let's just work together and okay. So what I did was to highlight everything and Control Shift F3 or just give this a name. Okay, but I don't like this actually this wait, put names. Okay, but anyway, that's what I did. So in the interest of time, so we can use the PMT function. I'll make it negative. You can make it negative, class, so that the answer will be positive. And you can do that for PMT, for FD, for PB, but not for rate, not for NPER, because these are cash flows. That's okay. All right, our rate is what? Our rate is 8%, right? I made that annual rate of interest, but we have to divide it by the periods per year. Okay, then comma. Okay, so our rate is 8% divided by 12 because this is monthly. Okay, this is monthly amortization. Therefore, the rate should also be monthly. If the payment is semi-annual, then the rate should also be semi-annual. There should be consistency. NPER is 15 years. However, since this is monthly, 15 also should be multiplied by the periods per year. So the number of years multiplied by the periods per year. All right. So 15 times 12, that's 180, right? Okay, then comma. Next is present value. Our present value is the amount that we'll be financing. Okay. Next is the future value, no future value, comma, comma. And then the type, you can set it to 0 or that's ordinary, or you can just leave it blank. So Control Enter. Let me flash that formula again. Okay. So this is our formula. For the rate, it's the annual rate divided by the periods per year. 8% is annual. Okay, but this is monthly amortization. So we have to convert this 8% by dividing it by periods per year, which is 12. On the other hand, the NPER, number of periods, will not be 15. Rather, it's 15 years, but each year has 12 periods. So that's 15 times 12. Then comma, amount of finance is this 4 million. And then this one is FV. So there's no future value. And then type is 0 because this is an annuity ordinary. Okay, so let me flash that for a few seconds. Maybe some of you would want to compare your answers with it. Okay, and kindly chat please if you have computed for the monthly amortization. Okay, any questions? I hope you're okay. I haven't seen 100% chat class. How about the others? Okay, good. All right. So the monthly amortization is 38,226. All right, let's work on this amortization schedule. So there are 15 years, okay, and 15 years and 12 months per year. So the number of amortization will be 180. Okay, I can start with 0. I think you know this already. And then here, I'm going to create a series. So here, okay, series. So I highlighted 0, series in columns, step value 1, and it will be up to 180. Okay? Okay. So we now have here 0, 1 up to 180 to account for the number of months in 15 years. All right. So starting with 0, when we borrow money, we'll get the 4 million, but we won't be paying yet. This is annuity ordinary. So at month 0, we get the money. We don't pay yet. So our principal balance will be equal to the amount to finance. All right, 4 million. All right. Then after the first month, at the end of the first month, we will now be paying. And the amount that we'll be paying is this monthly amortization. Okay, this 38,226. Okay, so the interest will be equal to, how much will be the interest? It will be equal to, for the first month, it will be equal to, how much was the principal balance? Multiply that by, we multiply that by the interest rate divided by the periods per year. So that should be the monthly interest rate multiplied by the whatever is the principal balance of the previous month. Okay, Control Enter. So I'm getting an interest of 26,000 for the first month. Kindly chat please if you got the same answer. It's already almost time. Class, can we just finish this? It will take, I think, 2 to 3 minutes. Okay, how about the others? Did you get this interest? 26,667. Okay, good. All right, good. Okay, then how much will be paid to the principal? So the total amount that we're going to pay is 38,226. Of this, 26 will go to the interest. Therefore, the principal payment will just be the amount we're going to pay minus what will accrue for the interest. So the monthly amortization minus the interest payment for that specific month. So this is the amount that will only go to principal. If we take a look at the answer here, okay, 11,559, 26,667. 11,559, 26,667. That's for the first month. Let's see. 11,559, 26,667 to the nearest centavo. Okay, it's okay, correct. And now, so after 1 month, the principal balance which we'll have is whatever the principal balance is of the previous month minus whatever you're going to pay to the principal. All right. So this now becomes the principal balance as of month 1, at the end of month 1. Okay. And then how much will be the interest? The interest will once again be equal to just like this. No? Whatever the previous balance was multiplied by the annual interest divided by the previous period. So we can copy this down. We can copy this. Okay. So you notice that the interest went down because the principal balance went down. Okay. And for this one, the principal payment will be whatever we paid, this fixed 38,226 minus the interest payment. So which means we can copy this down also. Okay, so you notice the principal payment went up. As your interest payment is going down, because your principal balance is going down, your principal payment is going up. So the effect is that your interest keeps on going down because your principal balance of the previous month keeps on going down, and also the principal payment keeps on going up. So that's why in this plot you can see here interest payments going up there. Okay, of course this was for the whole year na to, no? For the whole year. Okay, so this is what your assignment. So you create this plot for the whole of 2023, for the whole of 2024, 2025. Okay, let's make it that for 2023, our first payment will be June. Okay, June 20 or July 2023. Okay, so let's agree on that. So this one, this payment will be June 2023. Okay, so I would want you to create this plot exactly the same. Deadline of this is on Monday. I'll post. I'm going to create a folder, and then each of you will be posting your answers there. Okay. All right. So
Sir,
yes.
how did you get the interest and
Which one? First
yeah,
month.
this one?
This one.
Okay.
The interest is based on how much was the principal balance of the previous month. And then you impute interest on that by using the monthly interest rate, which is
Okay.
8% divided by 12. So it will be like that always. Okay. We're not using 8% because 8% is annual. Okay. We have to use the monthly interest rate. So you just divide 8% by 12. All right. So the month end principal for month 2 will be, okay, it will be this one minus the principal to be paid on the second month. I can just copy this. All right. Let's check. So it's the principal of the previous month minus the principal payment of this specific month. So once you have made this first, you can actually just copy this down. Let me just double click this. Okay. All right, there. Okay, and then it will up to month 180 there. So you notice that at month 180, it's already 0. And then we can, sorry,
Sir, what shortcut that you use again
shortcut,
to fill it in? The whole
Control Z. You can just use this shortcut. Okay, I'll delete this. Just highlight this one. Since there's a number here, okay, it will automatically carry on the formula. Here, the cross here. At the bottom right, this one. Double click there. Okay, any other questions, class? And then
Sir,
let's, yes,
can I see po yung yung formula for the principal po?
principal, okay, here. Principal is, just remember this, class, it's a story, no? Every month you're going to pay 38,226, okay? Now, some of this will go to the interest, and some of this will go to principal. Okay, so first you compute for the interest. How do you compute for the interest? Whatever your previous month-end balance is, principal balance, will be subjected to the interest of 8% divided by 12. Why divide by 12? Because this is monthly interest. So if you take a look at the interest here, it is the previous principal balance multiplied by the annual interest divided by the periods per year here, right? So that's your interest payment for month 1. How much did you pay? 38,226. How much will go to interest? 26. How much will now go to principal? 38 minus 26. This is the principal now. Okay? Did that answer your question?
Yes po, sir. Thank you
Okay.
po.
All right. Then, dito, sa month-end principal, will be yung previous month-end principal minus the principal at this current month. Okay? All right. Any other questions? No questions? All right. So let's see how much how much was the total interest. If we add all the interest here, we can use alt equal to shortcut for sum. So the total interest paid for this loan was 2.8 million. So let me copy this. Okay. And of course, you know that the total principal to be paid is the amount that was borrowed, 4 million. Total interest is 2.88 million. So very big, no? Total principal is 4 million. Okay, you don't need to add this principal. No point in adding that. All right. Okay, questions?
Sir,
Yes.
paano po yung shortcut ulit dun po sa month, yung 0 to 180?
What do you mean?
Dito po sa 0, then yung pa-column po.
Dito?
No po, di sa month po.
Okay,
Then
okay.
down, 0 to 180. Paano po ulit yung shortcut?
Okay.
Ay, yung ano po, yung parang,
Ito to. So I started this one with this one, yung ba?
no sir, sa month po. Like
Sa
yung sa 0, 1, 2, 3.
okay. Yung sa series, no?
Yes po. Paano po ulit?
I'll delete that. So 180, di ba?
Yes po.
Okay, so start with 0. Okay, you have to start with that one. And
Yes.
then dito sa home, tapos editing, kita mo to? And then dito, no? Here. You have this fill,
Yes po.
and then series. Okay? All right, James?
Yes sir.
Then series in columns, no? Pababa. And then step value by how much will be the increment by 1. Kasi every month. No? Step
Yes, po.
value is 180.
180.
180 months kasi, no?
Yes po.
180. And then okay. There.
Thank you sir.
All right.
Okay na po.
Okay, sige. So ang shortcut nito, highlight nyo lang to, and then double click. Yeah. And then we added it a while ago. Okay. Sa Mac, hindi ko lang sigurado, but sa Windows, Alt equal to yung sum para hindi na natin na-highlight. Control Enter. And then this one. All right. So your assignment, you have to submit this using Excel. Okay. Siguro, I'm going to, ito na lang. Sige, ito na lang. And then what you need to do is this one. I need you to plot. Kailangan ma-replicate nyo to May line din na ganito. Tapos yung bar chart, ganyan din. No? Ganyan. Everything should be the same. And you notice that the plotting is by year. Accumulate niya per year yung yung plot na to. Ano yung question mo? Okay, guys, sandali lang Carlo, could you kindly share your screen? Sandali lang.
Okay, sir.
Asan na yung ano natin? Wala yung Excel ko. Okay, stop share ako. Could you kindly share your screen, please? Let's just address this one problem here. And then let's call it a day. Sorry guys for the extension. If you have classes already, you may. Okay, akyat nga, Carlo, akyat nga. Go up, please, go up. And may I see your formula for monthly amortization? May I see? Go to B10. B10, may I see?
Oh, sir, I didn't get to copy the
Okay.
formula. So I
May I
will copy
see?
to them.
Oh, yeah, kaya kasi talaga hindi mag-e-exact yan kasi exact yung ano mo eh. Yung value ko is not 38,226, no? Just as I suspected, no? Hindi ka naglagay ng formula. Kaya hindi siya mag-zero kasi ito hindi naman so exactly 38,226. If I increase the decimal place, hindi naman yan ano, di ba? 38.08333732 yan, di ba? Eh, ikaw, kinapi mo lang. So, talagang hindi tayo magpapareho. Magkakaroon nga pa ng balance.
Yes,
Okay?
sir.
Carlos, so you have to use the formula. Hindi pa pwedeng kinapi mo lang yung value.
No, sir, because my Wi-Fi has been unstable the whole class. So
Sige,
I've been cutting in and out.
Okay, dapat ang gawin mo, no, ito, di ba, yung Control Shift F3, bigyan mo ng pangalan to. Put a name here. Highlight mo
Which-
to. Control Shift F3, no? Para mabigyan ng pangalan to mga cells. Okay? So, the cells now have names. Ito. Kaya ito. Look, it's now called loan principal. Whatever name we have here, some 20% down payment. Hindi kasi pwede magsimula ng percent yung name. Okay, and then I'll give you this. Okay, I'll copy this formula to chat para ma-check mo na lang, ha?
All right, sir.
Okay, para you check it, please. Sa chat. Here. Okay, also for those of you who were not able to follow that. So that's the formula. But make sure that you gave a name to the cells by highlighting them and then Control Shift F3 so that you can use this formula. You can just link to the cells and then lalabas naman yung names na yun. Okay?
All right, sir.
All right. So thank you so much, class.
Sir,
Any other? Yes.
ginawan ko na po nung parang monthly, pero yung nakalagay po dun sa ginawa po natin dun sa calculator is
Sorry, sandali lang. Okay. Those of you who need to go, you may do so, okay? So we're dismissed and I'll just entertain some questions. Sandali lang, I'll stop recording already also. Asan na yung recording natin? Bakit nag-ano tong screen ko? Stop recording.